Last meeting, I started to design beams, and I covered plastic analysis, how to calculate the plastic moment, and we have example, and how to classify the cross section to be compact, non-compact, or cylinder. And we said that compact section is the best choice. And we did more examples. Last meeting also, I covered what is the meaning of lateral torsion buckling. Lateral torsion buckling means the flange of that steel flange under compression will move laterally, will displace laterally. If the top flange or the compression flange displaced laterally, the cross section or the beam will rotate. So this is called torsional. And then buckling will happen. If this phenomenon happened, that means the beam is not efficient to support load. We can overcome this issue by using these bracing. Let's start our design for beams. Just to explain something for you. So if you have a beam, looks like this. And I told you last meeting, to prevent the lateral torsion buckling, I will connect this compression, this flange under compression by bracing. That's right. So I will not put bracing every 1 millimeter or every feet. I will put the bracing every spacing. This spacing between this support, lateral support, and this lateral support can be called LB. This LB can be called an supported length. Can be called an supported length. I have question. If this length is smaller, will be good. If this length is larger or longer, it will not be good. So we must support any beam laterally. The distance between the supports, which is bracing, for this example, this length can be called, or this spacing can be called unsupported length, LB. I have another question. What will happen if you have steel beam? And this steel beam is connected to concrete slab. Do you think we have a value for LB? What is the value of LB in this case? Actually, every single millimeter in this beam is connected to the slab. So the lateral support for this beam will be the concrete slab. That means LB equal 0. So sometimes we don't have a slab, like this case. So we need to add bracing. The spacing between each two bracing can be called unsupported length, which is LB. If you have a concrete slab supported to the steel beam, that means every single millimeter of this beam is supported by this slab laterally. I'm talking about supported laterally supported. So the unsupported length will be 0. So just to remind you, what is the philosophy of design? We have M ultimate. Do you remember what is the meaning of M ultimate? Yes, I remember. We have a beam under the effect of uniform distributed load, for example, W ultimate. This uniform distributed load will cause bending moment. This bending moment, the maximum value can be called M ultimate. So M ultimate is the applied moment coming from structure analysis. This applied moment, to be safe, this value must be smaller than or equal the design moment. So phi Mn are two terms. The first term Mn, which is called nominal moment, not nominal design, nominal moment, and the phi is the reduction factor for flexure, for bending. So if you have compact section and LB smaller than or equal LP, yeah, I understand what is the meaning of the first length. LB is the unsupported length that I told you before, LB. What is the meaning of the second length? LP. LP is a length from table. I'm sorry, what you mean? I gave you a table for design of beam. For this cross section, for example, you can find here a value for LP. For example, W36 times 529 has LP equal 14.1 feet. So, as engineer, you have to decide what is the spacing between bracing. Guys, did you remember this picture? So the engineer, the designer, decided he will put these bracing every, for example, 10 feet. So LB equal 10 feet. And then you will select a cross section. Based on your selection of the cross section, I will, from this table, I can define what is the value of LP. If the value of LB, which is unsupported length, is smaller than or equal LP from the table, I can say the nominal moment for this cross section equal F yield times ZX. What is the value of ZX? The plastic section models. From the same table, you can find ZX. I'm sorry. From another table. Wait a moment. Table of sections, yes. If you go back to the previous tables, for any cross section, we can find here a value for Z. Z about x-axis, which be ZX. If you multiply ZX by F yield, I can give you Mn. Then if you multiply Mn by phi, which is 0.9, I can give you the design bending moment for a beam. Actually, we can, or we don't need to do this calculation. F yield times Zx to find the Mn, and then the Mn times phi, which is 0.9, figure out the value of phi Mn. Actually, the tables for design of beam can give you this value directly. You don't need to do any calculations. Just go ahead and select your cross section. For example, W40 times 372. Your design bending moment is this value. 6,300 kib foot. That makes sense? So we have a column here, phi mn, directly, without any calculations. But if you would like to do your calculations, okay, mn equal F yield times Zx from the first table I provided you. Then the value for mn, which is nominal moment, time phi, which is 0.9, I can figure out the design. All of these calculations only if the unsupported length is smaller than LP. We have another case. So LB is the unsupported or unbraced length, is the length between points that are either braced against lateral displacement of the compression flange or braced against twist of the cross section. LP is the maximum unbraced length. We can get it from table. We have another case. If this condition is not happened, LB smaller than or equal LP, we have another condition, LB greater than LP, but smaller than LR. What is the value of LR? Please go back to the same table. As you have value for LP, we have another value for LR. So any cross section has two values, one for LP and one for LR. If the unsupported length in between, your design bending moment equal this equation according to AISC. Phi mn, which is a design moment, equals CB time phi m plastic minus phi bf time LB minus LP. How can I use this equation? It's very simple. The first part, CP, is a constant or a factor. Can you see this table? If you have simply supported beam with concentrated load, and this beam is laterally supported at this end and this end only, your value will be 1.32. If the same beam is supported at the two ends and the mid-span, your value of CB equal 1.67. If you have two concentrated load and your beam is supported from two ends only, 1.14. So based on type of loads, concentrated, one concentrated, two concentrated, three concentrated, distributed load, and the number of laterally supported point, how many bracing do you have through the beam, I can determine the value of CB. Phi M plastic, Phi BF, LB, LP, this one, and this one, and this one from table. Here is the value of Phi MP. Here is the value of Phi PF. Here is the value of LP. So any cross section, I can determine the value of Phi MP, the value of Phi BF, the value of LP, and the value of LB, which is unsupported length. It's a decision from the engineer. Let's do an example and see how can we decide you are in this condition or you are in this condition, and how can I use these equations. We have a beam, this beam with span 30 feet, and I assumed the cross section of this beam will be W 16 times 31. Steel A 992. It supports a reinforced concrete floor slab. This information is very important. Anybody can tell me what is the information from this one? It supports a reinforced concrete floor slab. If the steel beam is supporting reinforced concrete slab, that means every single inch from this beam is supported laterally. That means LB equal 0. That provides continuous lateral support of the compression flange. Continuous lateral support means LB equal 0. The surface dead load equal 450 and the surface life load equal 550. Does this beam have adequate moment strength? Do you think this beam is safe or unsafe? Let's start. W ultimate equal 1.2 dead load plus 1.6 life load. 1.2 time. What is the value of dead load? 450 plus 31 plus 1.6 times the value of life load 550. What is the value? So anybody can tell me what is the meaning of 31 that I got? 31, what does it mean? This value will be 1457.2. I can convert pound per foot. I can convert it to be 1.5 kb per foot. Guys, can you tell me what is the value here? 31. Thank you, Oliver. Yes. The problem did not say that 450 including the on weight of the beam. I didn't see this information. So I'm assuming the dead load is coming from the slab or coming from something different. So do you like to include the weight of the beam? Yes, I like. So how much? Okay, go back. We are using this cross section. Do you remember what is the meaning of 16 and what is the meaning of 31? 16 is the depth of the cross section. 31 is the weight of the beam bound per foot. So I added 31 to 450, which is the dead load. I added them together, multiplied it by 1.2, and the value of life load multiplied it by 1.6. So the final W here, W ultimate on this beam, 1.5 kb per foot. Can you draw the bending moment diagram? Yes, I can. It's simply supported beam under the effect of uniform distributed. Your value or your moment will be parabola. The maximum value here, W L square over 8. So M ultimate will be 168.75 kb foot. This is the value of M ultimate. LB equals 0. What is the value of LP? What is the value of LR? Okay, go ahead and open the table for W16 times 31. 16, 16, 16, 16. Did you see any 16s? 16s. I didn't see any 16s. Did you? I have here 16, but time 31. 16 times 31, almost. There you go. 16 times 31. What is the value of LP? 4.13. What is the value of LR? 11.8. What is the condition right now? Do you think LB smaller than LP? Do you think LB between LP and LR? We have two conditions. Do you remember? LB smaller than or equal LP, or LB between LP and LR. I think we are in the first case. So LB smaller than or equal LP. So the design bending moment equal phi F yield times ZX, or phi time M plastic, which is equal this value. For W16 times 31, your value will be 203. Here, foot. Without any calculations. This value, phi, Mn equal phi M plastic, or phi F yield times ZX. We can get this value from table. Which column? This column, phi M plastic. In this case, for W16 times 31, we have a value 203. Please go ahead and make a comparison between M ultimate and the phi Mn. M ultimate is smaller than phi Mn. The applied moment is smaller than the design moment. Safe. Done. Very easy. Very simple. One more example. But if you have any question, let me know. If you have any question, let me know. The second example determines the flexural strength of W14 times 68 of steel A992 subject to unbraced length LB. Unbraced length, how much? 20 feet. And the CB is given equal 1. Okay. Go ahead and search for W14 times 68. What is the value of LP? What is the value of LR? We need to search. 14 times 68. 14 times 68, I think we need to go up. 14. Here you go. This one. 14 times 68 for this cross section. What is the value of LP? 8.69. What is the value of LR? 29.3. Feet. So what is the condition right now? I think LB greater than LP and smaller than LR. So the design bending moment equals CB time phi M plastic minus phi BF time LP minus LB. Do you remember this condition? If LB greater than LP and smaller than LR, here you go, the design bending moment. Let's do it. What is the value of CB? You don't need to figure it out because it's given. 1. What is the value of phi M plastic? Open your table. Here you go. This column, phi M plastic, 431. Minus phi BF. Here you go. Here is phi BF. How much? 7.81. LP 8. I think I switched them. It should be LP minus LP. Are you sure? Yeah, I'm sorry. Okay. LP 8.69 minus LB, which is 20. Be careful because this one minus this one will be negative, time negative will be positive. I think I have a mistake here.
It's L.
Yeah, it should be LP minus LB. Because this value must be reduced. So I switched them. I'm so sorry. It's a mistake. It's a mistake on my note. This one should be LP, the greater one, minus the smallest one. Because I need this term to be negative, because this term must be reduced. So I have to switch them. I'm sorry, it's my mistake. So LB minus LP, 20 minus 8.69. This value will be 342.67 kb foot. So the design strength of this beam will be 342.67. So guys, please go back to your notes and fix it. LP minus LB, the biggest one minus the smallest one. And that makes sense. Another example. This example is coming from a professional engineer exam. We have single-story steel frame is shown below. The connection between the column and the beam may be assumed to be simple shear connection. This connection and this connection can be considered pin. What does it mean? It means this beam looks like simply supported beam, like this, with the uniform distributed load. Loads are shown, or loads shown are factored load. Wow, this load is W ultimate equal 8 kb per foot. It's W ultimate, yes. The problem said this. Load shown are factored. Factored means I multiplied it by 1.2 and the life by 1.6. So I can figure out the bending moment diagram on this beam. M ultimate equal WL squared divide 8. So the value of M ultimate will be 8 times 30 square divide 8, it will be 900 kib foot. The floor supported by the beam BC does not provide any intermediate lateral support to the beam. Wow. So we have information here. The floor supported by this beam BC does not provide any intermediate lateral support. So that means the unbraced length or unsupported length will be the whole length of the beam. We don't have any lateral support internally or in between. So the unsupported length will be 30 feet. Assume CB equal 1. Most of the time we are assuming this factor equal 1. And select a cross section for this beam. Actually, we cannot select, but we can. We will assume. Let's start to assume. What do you think? What we need to assume? Any recommendation? What do you think? Assume cross section W. Which one? Okay, go ahead and select anyone. Anyone? Be careful. What is the value of M ultimate? 900. So do you think this one will be good? Do you think this one W14 times 68 will be good? No. Why? Because the value of F5 M plastic is 400 only. 431. I'm looking to make sure M ultimate is smaller than phi MN. So your design moment must be something greater than 900. So I believe you are talking about 400. No, we need to choose bigger one. So be careful when you are assuming something. Be careful. All of this stuff does not work. All of them has value smaller than 900. We need to choose bigger one. Probably we can choose something from here. Okay, let's start with this one. Let's start with this one. W, I will assume. We need to assume and then check. W30 times 99. Okay, assume W30 times 99. What is the value of LP? What is the value of LR? Let's see. Value of LP equal 7.42. What is the value of LR? 21.3. Does not work. Does not work. Because LP greater than LR. We don't like this one. Actually, we can design it, but we don't like it. So this cross section does not work. Choose another one. Open the table. Probably we can choose I'm trying to choose more efficient one. Okay, let's start with this one. No, this one will not work because the value here is 800. We need 900. So, okay, let's start with this one. W 21 times 111. 21 times 111. What is the value of LB? 10.2. LP 10.2. LR 31.2. I think right now LB greater than LP and smaller than LR. So the value of phi MN equals CB times phi M plastic minus phi BF times LP minus LB. I'm sorry, LB, the greater one minus the smallest one. Put your number, CB equal 1. Phi M plastic for this cross section is 1050. Phi BF for this cross section equal 33. I'm sorry, 18.9. This is the cross section. 18.9. 30 minus 10.2. What is the value? Let's see. 30 minus 10.2 times negative 18.9 plus 1050. You will have 675.78. Keep foot. M ultimate, unfortunately, M ultimate, which is 900, greater than phi MN, which is 675.78, unsafe. You need to choose another cross section. Okay, go ahead and choose another one. Do your calculation until you found this value greater than or equal at least 900. Then this cross section will be safe. So design of beams for steel will be trial and error. You have to assume, you have to check, and finally make sure that M ultimate is smaller than or equal phi MN. Any question so far? Any question so far? The second one, or the second part in our meeting today, shear strengths. Guys, there is a big, very important information here. You have to know it. If you have cross section like this one, the only part of this cross section supporting shear is this part, which called the web of the cross section. Does it mean this part will not support? Actually, these parts are supporting, but very, 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 very small part. The only part or the main part supporting shear is the web. So if you would like to determine the nominal strength of shear, equal 0.6 F yield times area web. Area of web. How can I get the area of web? The total depth of the cross section D times the thickness of this web T web. Make sure that V ultimate, which coming from the structure analysis, is smaller than or equal phi Vn. For shear, we are going to assume phi equal 1. It's very, very, very easy to check of shear. Let's do an example. We have simply supported beam. Simply supported beam between two supports. with the span length, the total length is 45 feet. Is laterally supported at its end and is subjected to the following surface load. We have dead load, how much? 400. Including the weight of the beam. Including the weight of the beam. So 400 is including everything. Life load equal 1000. Can you tell me what will be the W ultimate? Yes, I can. 1.2 dead load plus 1.6 life load. The value will be 2080 pound per foot or 2.1 kb per foot. So we have uniform distributed load here. How much? 2.1 kb per foot. If you go back to structure analysis, we have a reaction here. We have a reaction here. How much? 2.1 times 45 divide 2. This one will be 47.25. This one will be 47.25. The shear stress, the shear force diagram will be like this. The value here will be 47.25. The value here will be 47.25. This reaction and this reaction. That means the value of V ultimate from structure analysis, 47.25 kb. This is the value of V ultimate from structure analysis. Do you think if we are using this cross section, W14 times 90, will be good, will be safe or not? Okay, W14 times 90. What is the depth? What is the thickness of the web? I will open the table, the previous tables, for cross section W14 times 90. 14 times 90. No, we need to go down more. 14, almost 14. Here you go. 14 times 90. No, we need to go down more. 14 times 90. Here you go. This one. 14 times 90. What is the depth? That makes sense. 14 inch. What is the thickness of the web? Where is the web? Here is the web. Thickness of the web will be 0.44. So area web will be the depth 14 times the thickness of the web 0.44 will be 6.16 inches square. Vn, as I told you, equal 0.6 times F yield times area web. 0.6. What is the value of F yield? What is the type of steel here? It's not given. No. It's given here. If F yield equal 50, so it's 50. Time area web 6.16. What is the value of Vn? 184.8. So phi Vn, phi will be 1. Time Vn 184.8. The final value 184.8. Do you think V ultimate is smaller than phi Vn? Yes. Because V ultimate is 47.25. Phi Vn is 184.8. So the cross section will be safe. Safe what? Against shear. And the previous example, the cross section was safe against moment. So just to remind you, any beam under the effect of load will have shear force diagram and will have bending moment diagram. Shear force diagram will give you V ultimate, bending moment diagram will give you M ultimate. To make sure this cross section is safe, you have to check moment and you have to check shear. Both of them must be safe. So M ultimate must be smaller than or equal phi Mn. V ultimate must be smaller than or equal phi Vn. Both of them and, not or, and both of them must be safe. Doesn't make any sense to say the shear is safe, the moment is unsafe. That means the cross section is unsafe. Your cross section must satisfy moment, must satisfy shear. Shear is a piece of cake. Just what is the value of V ultimate from structure analysis? The value of Vn is 0.6 times F yield times area web. To get the area web, you need the depth of the cross section and the thickness of the web. And the F yield will be given. You can figure out the value of Vn. Phi will be assumed 1, so you can get the design shear strength. Then you can make comparison. So we learned today, if we have a beam under the effect of load, we can get from structural analysis M ultimate, then we can assume cross section, or probably it will be given. Then we can check and make a comparison against the moment and against the shear. That's enough for today. If you have any question, let me know.
It's a stupid question. It's kind of old. It's about structural analysis.
Yeah, go ahead.
Would you mind just doing a quick sketch of so if you have a simply supported beam or just any beam, you have distributed load. Let's say the beam is about 10 foot long. Then you have distributed load, and then as well as concentrated load. Let's say at 3 feet from support A or whatever. Can you draw the shear diagram?
Okay.
Just to refresh my memory, I'm really sorry.
Yeah, that's fine. Anyway, if you have a problem like this and you are not familiar or you are not, you cannot remember, you can use RISA. Okay, this is the first step. The second step, what should I do? If we have something like this, this one is 5 kip per foot. This one is 20 kip. These lenses are 5 feet and 15 feet. A, B. Keep in your mind, if you have uniform distributed load with something inside, go ahead and divide it. I'm sorry. The uniform distributed load here over the whole beam, 20 feet. But we have intermediate concentrated load. 100% recommendation to what is the equivalent for this part alone. What is the equivalence for this part alone? You have to do this. So 5 times 5 will be 25 kip for this part only. 5 times 15 will be 75 kip for this part. Go ahead and figure out what are the reactions. If you take moment at A, equals 0. So we have 25 times 2.5. We have this concentrated load 20 times 5. We have 75 times what? What is the distance between this point and this point? 12.5 minus reaction YB times the whole distance 20 equals 0. So I can figure out the reaction of YB. This reaction will be $55. So this reaction is 55. If you apply summation f of y equals 0, I think I can figure out the other reaction. It will be 65. Okay. Any question? So the key in this kind of problem, if you have uniform distributed load, on this beam like this, without anything inside, go ahead and get the equivalent value for the whole distributed load one time. But if you have uniform distributed load with something inside, anything inside, like concentrated load, for example, if you have two concentrated load, what should I do? You have to divide this distributed load to 3 parts. This part alone with equivalent, this part alone with equivalent, this part alone with equivalent. That makes sense? Once you did this and find your reaction, let's start to draw shear force diagram. I will go up by 65. We have uniform distributed load, so I will go dotted, go down by 25, so I will reach 40. Dotted, then we have 20, this concentrated is 20, we are at 40, so I will go down by 20, so I will reach 20. We have another distributed load, so I will move uniform distributed load. We have here 75 at 20, so I will go down to 55. Keep walking until 55, go up. From this dotted line and this dotted line, I will draw solid line. From this dotted line and this dotted line, I will draw solid line. Here is the shear force diagram. Negative, positive. Brock, any question for this step?
No, sir. That's great. Thank you. So when you first go up 65 and then you go down, and then you dot, and then you go down 25, that point, the 2.5 length, you go slanted. It's not straight, correct?
Say it again.
Basically, the shear force diagram, you're always going to go down slanted because there's distributed load, right?
Yes, yes.
You don't walk straight. You're walking downwards.
Yeah, yes. Yeah, I can do this by using the dotted line. Can you see the dotted line I did?
Yes.
Will help me to figure to set up the inclined line I draw later.
Sounds good. Thank you so much.
Okay. Yeah, if you have any issue with any beam, you can use RISA if you cannot figure out what is the shear force diagram or bending moment diagram.